Hi, U10s. In this video, I'm going to be going through index laws, and of course, we're just going to be reviewing the index laws, which means that we're hoping that you have seen a lot of these in Year 9. Now, of course, we've had a lot of disruptions due to COVID and things, so I'm not sure. Maybe some of this you haven't seen, but I'm going to guess that you've been through all of this, and this is revision. But mind you, it all happened so long ago, and our algebra is going to be at all different stages. So I just want to talk about these laws, and in particular, we're looking at the index laws, and the law one is when we multiply indices of the same base. So what we're looking at in indices, we're looking for we're looking at powers and uh, so we retain the same base. So if I was to do, say, m to the power of 5 times m to the power of 7, for example, then you can see that this is the base of the indices. So this is what we call the base, and then we've got the power. Okay, so now it says that if we have, so law one states that we retain the base and add the indices. We could also think about, like, if we could have numbers as a base too. So if I had like 2 to the power of 3 times 2 to the power of 4, well, let's write this out in expanded form. That's like 2 to the power of 3 is 2 times 2 times 2, and I can put that in brackets if I wanted to. And if I had 2 to the power of 4 is 2 times 2 times 2 times 2. Now we could ask ourselves, how many 2's do we have? We've got 1, 2, 3, 4, 5, 6, 7. So we could write this out as 2 to the power of 7. So what do you notice? That if I've got indices of the same base, then I can, so I've got two indices of the same base, the base 2 to the powers 3 and 4. Then I add the powers. Okay, so that's going to be law 1. Now, likewise, if we've got law 2, we can say that if indices are the same base, when we're dividing, then we're subtracting. So, for example, let me do another example. If I've got 5 to the power of 4 divided by 5 to the power of 2, well, we could write that in expanded form as 5 times 5 times 5 times 5. And I could write 5 squared as 5 times 5. Now, we know that when we're multiplying, we can do some cancelling, can't we? We're multiplying, so we've got 2 5s on the top, 2 5s on the bottom, and what we're left with is 5 times 5, or 5 squared. Okay, 5 times 5 is 5 squared. Well, what do we notice with when dividing? Well, what you can hopefully notice is that I'm getting 5 to the power of 4. I'm subtracting 2 away. 2 take away from 4 is 2. Okay, and that's going to be 5 squared, which of course we can evaluate as 25. You can have m's and n's and stuff. It's obviously just seems like it's a bit more intuitive when we're looking at a number as a base rather than a letter at the moment when doing these. So there you go. That is law 2, and then we've got some other laws. We've got the inside bracket law, where we are retaining the base and multiplying the indices. Let's have a look at that one. If I was to have this, I'll do so. Let's say if I've got 2 squared. Oh no, let's do this. Let's do 2 squared to the power of 3. Well, what is that? Well, first of all, 2 squared is 2 times 2, isn't it? Let's do that. 2 times 2. And to the power of 3 means we're multiplying it by itself 3 times. So we could go times 2 times 2 times. So the good thing about these is you can just write these out. And until you start to see these patterns, you could do that if you really wanted to. Clearly, you shouldn't have to do this to solve this problem, but let's have a look. How many 2's do we have? 1, 2, 3, 4, 5, 6. So if I've got 2 indices, if I've got an indice in brackets, we are multiplying the powers. Let's have a look. So law 3, we've got that a to the power of m to the power of n is a to the power of m times n. So we're multiplying the powers. Okay, and likewise we can do that. So law 4 is very similar in that we can just do that for two separate ones. Okay, and we'll go through that. And then likewise we can do it with fractions. Okay, so really if you think about it, a lot of these law, it's really essentially three laws, and then law 3 is really split up for you know just it's really just very similar. Okay, so we might as well get started with some examples. And I think that for the most part, you're going to find some of these easier. It's when we're trying to bring them all together at once, and we obviously do that, and we do some quite big problems with these. And you've got to remember, you just got to take it one step at a time. Just take it one step at a time. And if you can apply your laws independently and bring it all together, that's the best way to go about doing these. Okay, so you should find these pretty straightforward. Simplifying, first of all, we've got law 1. So first of all, I've got two indices of the same base, and I'm multiplying them, which means that I'm not multiplying the powers, I'm adding the powers. If I write it out in expand form, it's x times x times x times x times x. That's x to the power of 5. And then I'm multiplying it by x times x times x times x, x to the power of 4. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, or we could likewise just add the powers. 5 plus 4, if you like, is x to the power of 9. Okay, now just remember that when you've got numbers, you need to multiply those numbers first, just like we've always done in algebra. Okay, and likewise, you're going to have to add the powers of the same base. So we're talking about a has the same base as a. So a squared has the same base. There's different powers, but it's a. And look, there's really an invisible 1 there, isn't there? There's an invisible 1 here as well. Okay, so let's do this. So 3 times 4 is 12. So 3 times 4 is 12. Let's work out what the number is, and let's get that out the front. A squared times a to the power of 1. We're adding the powers. A to 2 plus 1 is 3. B to the power of 1 plus 3 is 4. And you can simply do it like that. You're not going to write it out like this, are you? B times B times B times B. Oh, there's 4 B's there. By the way, that's not equal to 4B. I see that a lot. Okay? That is a common algebra mistake. No, you cannot do that. It is B to the power of 4. It is equal to B to the power of 4. Okay, now I'm going to pause this now, get you to have a quick go at this. Very quick go at this. Just get some paper in front of you. Give these a go. If you've got your notes in front of you, have a go at this now, and I'll reveal my answer shortly. Okay, I'm hoping that you had a go at it. Well, what are we doing? We're just using law 1 where we're adding the powers. So we're looking at x to the power of 3 times x to the power of 4 is we've got two indices of the same base x. We are adding the powers. 3 plus 4 is 7, and we're done. And 2 7s are 14. So work that out first. If you've got fractions, work that out and maybe even simplify that. 2 7s are 14. You can do this in one step as well. Try not to break things up into, and have stuff all over the place. Try to have work and logical working that flows. Now, we've got a little a to the 1 there, technically, because we know that you can do this if you like. That is going to be a cubed. So a 1 plus 2 is 3. And then we've got, well, you can do it like this if you like, because at least it makes some sense. 2 plus 3 is b to the power of 5. Okay, that there is logical working. What is not logical working is if you go is equal to 14 and you're going a the 1 plus 2, and then you're going times b to the power. Like, just no. If you need to do a little bit of working over here, like you need to work out what that is, you can do it on the side there, and then there's your answer. Okay. All right, now this time, example 2, we're looking at law 2, and we have said that two indices of the same base, we are, well, you know what we can do? What is m in expanded form? M times m to the power of 7 is this, isn't it? That's m to the power of 5, m to the power of 6, m to the power of 7. Now, if I have m to the power of 5 and I'm dividing, it's m times m times m times m times m. Yes, it's not the greatest way to do it, but hopefully you can see, though, that I've got 1, 2, 3. Okay, we've got another one, another one. I've just cancelled out 5 from the top and 5 from the bottom, leaving us with m to the power of what? M to the power of m times m is m to the power of 2, isn't it? So therefore, we can say that m to the 7 divided by m to the 5 is m to the 2. Well, really, how do we get that? I'm getting the 5 and I'm subtracting it. Later on, we're going to get into negative indices. Like this power can be a negative. So we're also got to be careful. If that was a negative 5, we might have to subtract negative 5. We'll get to that later, though. Okay, so m squared is this one. So of course, now let's write it out as a fraction. Step 1, write fraction. So we've got 4x squared y to the power of 5 divided by 8xy squared. Later on, we're also going to look at some like this could be squared if you like, and we're going to have to work that out. Okay, and it can be tricky at first. All right, now first of all, let's have a look at the numbers. Now clearly, it's always wise, let's try and simplify this fraction. We've got 4 divided by 8. So I think the best thing to do to both sides would be to divide by 4, okay? Divide by 4, divide by 4. Let's get the number, okay? So if I'm getting the number right, if I'm dividing the top by 4, that's going to just give me 1. So I've actually got x squared y to the power of 5 on top. That's a 1, and it's like 8 divided by 4 is 2. So in other words, 4/8 is the same as a half, and we can just write that 2 on the bottom. Okay. Step 1, deal with the numbers and simplify fractions as you hopefully know how to. Now, we now need to work our way across if we can, but of course, if I'm working our way across, we're not multiplying two indices that have the same base. X and Y are different bases. So what we've got to do is, in this case, we've just simply got to work down, and that's law 2. Okay, law 2 is that if I've got two indices, I'll just say an indice of base A. Let's say it's a power m for Mary and n for Nelly, then that means that we are going to subtract n from m. That is law 2, okay? That is law 2. So likewise, we've got a little 1 here. It might be worth writing that down. But by the way, the 2, we've simplified that fraction. That does not go anywhere. The amount of times that disappears, you would be surprised. 2 take away 1 is 1, so that's going to be x. I'll write a 1 there, but of course we don't need to write x to the power of 1 in algebra, do we? And 5 divided by 2. So if you want to do it, don't break up your good working down here. Keep it logical. If you want to, go like this. What is y to the power of 5 over y to the power of 2? Well, that's y to the power of 5. Subtract 2, or if you're really, really, really struggling, you could actually go, okay, well, that is this. Okay, so that's going to be y times y times y. There's 5 y's and there's 2 down here. 2 of them cancel. Look at that, y to the power of 3. Okay, so that is y to the power of 3, and it's there. So we're done, except really we wouldn't write x to the power of 1, would we? We'd just write x. If it's any other number, you can write that number, but if it's 1, just leave like that, and there you go. There's our answer. There's our answer. Okay, so I hope you've now practiced some law 1 and 2s. Now, can I get you to practice these ones? It might take you a little bit longer to take I don't want you to do this in 30 seconds because I think that B would take you longer, but hopefully you can see that what we could write m to the power of 5 divided by m to the power of 3 is, if you like, m to the power of 5 take away 3, which is m squared. But can I get you to try this now and have a go. In your notes, fine. If you don't have your notes, do it on a piece of paper. All right, I'll reveal my answers shortly. All right, so you can see there that that's my, let's write it out as a fraction for starters. Now we know that 5/10, if I was to divide the top by 5 and the bottom by 5, well, hopefully you can see that that's okay. So that I'm just going to write as a half. There's a 1 on the top and a 2 on the bottom. You don't need to write a 1 on the top, do you? Okay, so if it's a half, we've just got a 2 on the bottom. So that's the first step. Then x squared divided by x. Well, x squared, now I've done the working up here, and you don't have to do this, but I'm just showing you that x squared divided by x is x squared divided by x to the power of 1, and 2 take 1 is 1. So there you go. We've got x to the power of 1, which we just write as x. Then you've got y to the power of 4 divided by y squared. You could write it out the long way, which you've been doing, but hopefully you're getting the idea that we are subtracting that power. So 2 from 4 is 2. It's going on the top, and then you don't forget you've got to divide it by 2 on the bottom. Okay then, now let me just quickly go through law 3. And law 3, we've stated that in brackets that we're multiplying the powers. Okay, let's look at it again. Let's look at it again because and show you why that is the case. First of all, I will expand these and show you the ones. A cubed is A times A times A. Now, if I was to do that to the power of 4, I'd have to multiply it by itself 4 times. A times A times A. We're running out of room here, aren't we? But we will do it, and we might need to borrow some room from this question here. As you can see, there's, actually, we've got that, and then finally we've got that. Notice that we've got A cubed to the power of 4. 1, 2, 3, 4. And if you was to count those out, you can hopefully see that that's A to the power of 12, which, of course, is if I get this and I multiply it, then, so when we're in brackets, we need to multiply the powers. The problem is over here, when you see something like this, so that's done. But then this one over here, A12, A to the power of 12, sorry. And over here, let's write, look, we could write it out. 2y to the power of 5. The problem is 2y times y times y times y times y. And then you've got that 3 times. Okay, so I know that you would never do it like this if you understand y times y times y times y times y. Now I'm going to have to borrow some room over here, but 2 times y times y times y times y times y. Okay, now clearly you should not have to do this, but just be careful. This is what I see a lot. I see students doing all sorts of things. I see them going to 2 plus 2 plus 2 is 6. Okay, it's not 6 because it's 2 times 2, which is 4, times 2, which is 8. Or we could do it the short way, and that is I've got a 2 to the power of 1 there, 2 to the power of 1. What are we doing when we've got in brackets? We multiply the powers. So 1 times 3 is 3. So that's going to be 2 to the power of 3. Now we know what 2 to the power of 3 is. Well, 2 to the power of 3 is 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. We'll get to that in a second though. We'll just write 2 to the power of 3. And then we've got y to the power of 5 times 3 is 15. Now look how many y's we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you follow the laws, the index laws, you certainly don't have to do this, but I think it's nice to know why we do this. Okay, now 2 to the power of 3 is 8. Y to the power of 15 is our simplified answer. Okay, I'm going to need to rub some of that off, and so I will. And as you can see, let's do C here. Now, what are we doing with this one? It's really, so if we go back over here, we're looking at our laws, and our laws, so we've done adding powers, when we're multiplying with the same base. When we're dividing with the same base, we're subtracting the powers. When we have in brackets, we multiply the powers. When we have in brackets with two things multiplied, we have them separately and apply this law separately. And over here, if we have in brackets, well, we just apply the top and the bottom separately. That's basically all law 5 is. Really, if you like to think about it, really law 3 and 4 and 5 are really the same thing, but just applying our sort of fundamental algebra concepts that we should already know. I know that some of us are probably, will make, bend the laws sometimes and have all sorts of things. But yeah, at the end of the day, those three laws really are very close to each other. So let's do this. First of all, I'm going to write a 3 to the power of 1. The reason why I do that is because, of course, 1 times 3 is 3. And if I'm applying that, it's going to be 3 to the power of 3, and we'll deal with that later. We'll simplify it later. Notice we're multiplying the powers. I'm not going to write an expanded form, but x squared to the power of 3 is we're multiplying the powers, x to the power of 6. And then we've got 5 to the power of 1 times 3 is 5 to the power of 3. And then 2 times 3 is 6. 2 3s are 6. And z to the power of 1 times 3 is 3. Now, as you can see, can we simplify this any further? Well, yeah. 3 to the power of 3, 3 cubed. It's not 9. It's 3 times 3 times 3. That's going to be 9 times 3 is 27. So we've got a 27 on top. The question is, do we have any indices of the same base which we can simplify? No. X is a base. There is no x's or there's a y, but y is its own base and z is its own base. So we can't simplify any further. So in fact, our answer is x to the power of 6 over, now 5 cubed, 5 times 5 is 25. You can use a calculator if you like. 5 cubes is a common one, which I'd expect you to know though. Times 3 is 125. We can just leave it like that. Y to the power of 6, z to the power of 3. I put a little line through z because it can be very confusing. Our z's can look like 2's. Just trust me on that one. Okay, now, finally, we'll do this last one, which sort of combines a couple of laws in one. First of all, we've got to notice this 3 is outside the bracket. This is outside the bracket. So we don't apply that index law. We just multiply everything by 3. Okay, so let's do it. Inside the bracket, we've got x to the power of 1. That's x to the power of 1. 1 times 3 is 3. So it's x to the power of 3 and y to the power of 6. But don't forget, we've got a 3 out the front, so we're going to have that. So we've just done that bracket. Then we're going to do 4x to the power of 4, and I'm not going to do another law. I'm just going to do the bracket one. Okay, so the bracket has been handled. We now do not have any brackets. This is where I want you to, when doing this, I think it's a really good idea to work your way across. Okay, work your way across like this. Okay, so as you can see, I've got 3 4s are 12. Okay, so let's do that. 3 4s are 12. And look, we'll do the 8 on the bottom and we won't simplify the fraction yet. But let's apply our laws. Again, these things in isolation are pretty straightforward, but when you bring them all together, that's when it takes a bit more practice. We've got x to the power of 3 times x to the power of 4. Well, we know that if I multiply those out and expand them, that's going to be x to the power of 7. There's 7 x's. So there you go. That's going to be x to the power of 7. And I'm doing it on the top. I'm not changing anything on the bottom. There's nothing on the bottom to be simplified with yet. We're not working our way across the bottom. We're just working our way across on the top. Now that's going to be y to the power of 6 plus 2 is 8. Okay, now what I'm going to do is, again, I'm going to write a 1 here because that's handy to know when doing our index laws. And now we're going to work our way down. Okay, notice that we don't need to use law 1 anymore. When we're adding the powers, we're simply just got an x on the top and a y on the top and then on the bottom, and we're going to simplify those now. But before we do, let's do something, and that is I'm going to divide. What's the highest common factor? What goes into 12 and 8? 4, 8, 12. So I'm going to do divide by 4, and if I do that, that's going to give me my simplified fraction. So that's going to be a 3 on the top and a 2 on the bottom. There you go. Deal with those numbers first. Now, what are we going to have for this? If I was to do this separately, I'm going to have x to the 7 over x to the squared. Yes, you could write it out like this. And if you do that, then look, we've got 1, 2, 1, 2. We've got how many x's left? 1, 2, 3, 4, 5. You shouldn't have to do it that way, should you? Use your law. 7 take 2 is 5. Okay, so that's x to the power of 5. We're almost done because now we just need to do the same to the y. We've got a y to the power of 8 divided by y to the power of 1. We should hopefully know that 8 take 1 is 7. And look, we're done. We've got a simplified fraction. We've applied our index laws. We'll get some bigger ones of these. They'll get bigger and bigger, and they'll look ugly. But really, if you just apply the laws independently, then you really can't go wrong. Okay? Like, what did we do with this question? First of all, we did the numbers. Okay, get the numbers. 3 4s are 12. We didn't really deal with anything yet, but what I did is I worked my way across. Here, and I was doing the x to the power of 3 plus 4 is 7. Then after that, I didn't try and simplify any fractions, or I simplified fractions here when I went down to here, and then I applied my laws. As you can see here, these two are prime numbers, and we now have that simplified. Okay, now I'll get you to forget about these other ones. I want you to try this one now. Okay, try this now. I'm going to reveal my answer shortly. I'm not going to go through it a great deal. I just went through one of them, but have a go at this now, please. All right, I trust that you're trying these. I'm going to go through this very quickly, but I'm not going to explain as much as I have in the past. Now, first of all, let's do the brackets. 2 times 3 is 6, and 1, be careful, 1 times 3 is 3. Okay. Then I'm going to just do the bracket, and then I'm going to work my way across. I'm not going to deal with we could deal with the numbers. 4 times, if you like, there's 4 times 2 is 8, divided by 2 is 4, or we could cancel out a 2 on the top and a 2 on the bottom. There you go, dealt with the numbers. We've just got a 4 on the top. Now, x to the power of 6 times x is x to the power of, so I'm working my way across now, is x to the power of 7, adding the powers. And likewise with the y's, 3 plus 2 is 5, adding the powers. Okay, and likewise we've got this, and then look, that's a 1. 7 take 2 is 5, so that's 4x to the power of 5. You know why that is, because, hey, that's what we're doing over here. Okay, that sort of thing. But use your index laws. And finally, y to the power of 5 take 1 is y to the power of 4. And that is our answer. Got to work and practice with these. Again, you're going to, especially with the fractions ones, you'll need to find your feet with these. Okay, the final law, and that will do us for today, is that there is the zero power. Okay, now what we can say is this: anything, that's anything, to the power of 0 is equal to 1. So over here, if you break this up, we've got 4 times a to the power of 0. You've got to be very careful. A lot of students think that this is 1. No, because, well, a to the power of 0 is 1. Then that's going to be 4 times 1, which is equal to 4. If we apply it with this one over here, then we should hone it, that's 2 times p to the power of 0. Plus, look, I've got all of this inside a bracket. I've got 3p to the power of 0. Anything to the power of 0 is 1. So because that's in the bracket, that there That there is equal to 1. And then we've got over here 2 times 1. Now, if I go from left to right and I go to multiply my thing, so 2 times 1 is 2, plus 1 is 3. Okay, so finally, anything to the power of 0 is 1. Let's have a look at that. Anything. Anything, it doesn't matter what's inside that bracket. If the power of 0, that result is 1. Over here, though, p to the power of 0 is 1. Don't forget that that's 2 times p to the power of 0, which means that it's 2 times 1 because anything to the power of 0, p to the power of 0, is 1. 2 times 1 is 2, 2 plus 1 is 3. Okay, so there you go. That is the zero law and something just to add at the end there. So hopefully now you can see that we've applied index laws with common bases. So we can see here x is a base, x is a base, y is a base, y is a base, multiplying and doing the numbers separately and each indice of the same base. Likewise, we've done the ones with division, and also we can simplify using a number of index laws. We're starting to get there. We'll do much bigger ones, in fact. And of course, if you've got your notes in front of you, if you want to see how you're going, you could even try some of these questions which have been taken from the past test. I know that's a long one, there's a lot to go, but what you'll find is that these next few exercises will be much easier if you can review and bring all of those laws together. All right, thanks everyone, and hopefully I'll see you in class or around the school soon. Ciao.